This example says, given the quadratic function in vertex form, address the following. Our function f of x equals -4 times x minus 2 squared plus 4. Part A, what are the coordinates of the vertex? So as the directions mentioned, this is a function in vertex form, and vertex form is f of x equals a times x minus h squared plus k. Our function is written in that exact form, -4 times x minus 2 squared plus 4. So the important thing to memorize about this is that the h and the k stand for the vertex. So we really don't have to do any calculation to figure out the vertex. We just need to line up these positions in the function. So the h and the 2 are in the same place, the k and the 4 in the same place. So our vertex is 2, 4. So this quadratic function has a vertex of 2, 4. The next part says, does the graph open up or open down? We can figure this out based on the value of a. Our value of a is -4. And because that is negative or less than 0, we know that this parabola is going to open down. So we would answer opens down. The next part, what is the equation of the axis of symmetry? So axis of symmetry, so for a parabola, let me draw an example of a parabola, which I'll erase later. If you have a parabola, the axis of symmetry is going to pass through the vertex. The vertex, remember, is HK. And it's going to be a vertical line that passes through the vertex. So it's called the axis of symmetry because we're going to have a mirror image around that axis. Now I've drawn it so it's kind of right on the y-axis, but anywhere you draw that parabola, let me just kind of draw it in a different spot. If you draw that parabola in a different spot, you have the vertex at HK, and if you draw a vertical line going through that vertex, you're going to get a mirror image on both sides of that line. So that is the axis of symmetry. So notice each time I've mentioned that it's a vertical line that passes through the vertex. So because it passes through the vertex, we're going to use that x coordinate of the vertex to help us get that axis of symmetry. So our axis of symmetry is a vertical line. The equation of vertical lines is always x equals. And our vertical line is going to be x equals 2 because that's where the x coordinate of our vertex is. So we have the axis of symmetry being the line x equals 2. Okay, the next part says find any x-intercepts. So let's find our x-intercept. The way you find an x-intercept is by letting y equal 0, and we know that the symbols f of x has the same meaning as y, so we're going to set f of x equals 0. 0 equals -4 times x minus 2 squared plus 4. And then I want to solve this equation. I'm going to solve this equation by using the square root method. The square root method has you isolating this square and everything that is attached to that square. So I want that x minus 2 squared to be the only thing on one side of the equation. So I'm going to subtract 4 on both sides. That gives me -4 equals -4 times x minus 2 squared. I'm going to get rid of that -4 by dividing by -4 on both sides. That gives me 1 equals x minus 2 squared. So now I've isolated that square on one side of the equation, And the name of the method sort of gives it away. I called it the square root method, and we do the square root to get rid of the square. So we're going to square root on the left and square root on the right. The square and the square root cancel each other out on the right, and on the left, square root of 1 is 1, but I also need to throw in a plus or minus symbol. The plus or minus symbol has to do with the square and square root. We need to consider cases of plus and minus to account for that square root canceling out the square. So plus or minus 1 equals x minus 2. I need to continue solving this by adding 2 to both sides. So now I have 2 plus or minus 1 equals x. The plus or minus is two possibilities, 2 plus 1, which is 3, and 2 minus 1, which is 1. So now we have our x-intercepts of being 3 and 1. So I'm not sure if I'm supposed to write them as ordered pairs or just write them separated by comma. My guess is separating the intercepts by a comma. The next part says find the y-intercept. Okay, y-intercept. Y-intercept is when x is equal 0. So I'm going to find f of 0. Everywhere I see an x, I replace that x with a 0. So negative 4 times 0 minus 2 squared plus 4. Negative 4 times negative 2 squared plus 4. I'm following order of operations. I did what's inside the parentheses first. Then I'm going to apply the exponent. So negative 2 squared is a positive 4 plus 4. Negative 4 times 4 is negative 16 plus 4. Negative 16 plus 4 would be negative 12. So I've got my y-intercept being negative 12. The next part says sketch the graph and use a graphing tool. So I'm going to plot my vertex. My vertex is at 2, 4. I found x-intercepts at 3 and 1. I have a y-intercept at negative 12. And the important thing to remember is that these are not just random points. Our point right here of 2, 4 is the vertex. That is the point where this graph is going to turn around. And remember, we said earlier that this is going to open down, so it's going to turn around opening down. So I'm going to draw a little peak there at that point and then go through the other points. So there's my graph. The final parts are to find the domain and the range. So you could do this by memorization. A quadratic function is a type of polynomial function, and all polynomial functions have a domain of all real numbers. But you could also use the graph to tell you. Taking a look at this picture, if I look from left to right, I can see that this part of the graph is going to continue to move further left and left. So every x value is going to get covered from negative infinity, and because of this arrow, all the way to positive infinity. For the range, I can see that these y values down here are covered, and the y values are all going to get covered up until you get to where that vertex is at 4. So the range is going to go from negative infinity to 4 with a bracket on the 4. That's including the 4. Thank you for checking out my videos. Have a great day.